Coming up next, we have Tux Pacific telling us about his cool new project.
Entropy, first ever decentralized asset custodian protocol. So what is an asset custodian? Generally regard asset custodians as trusted individuals or organizations that will hold assets on behalf of another individual or organization. Custodians generally store assets, crypto assets, in cold storage mechanisms, or they leverage, threshold signature algorithms and multi-party computation to sort of securely store those assets without putting the funds at risk, or if any party gets compromised or hacked or something like that. Additionally, sometimes we'll see certain product offerings that allow their users to engage in DeFi and maybe the wider blockchain ecosystem. But this is kind of generally pretty rare, especially when they offer it through staking. Coinbase attempts to do this. Fireblocks is another, but generally it goes only halfway there. You can't do as much with your assets as you want. You can't vote generally, nor can you really delegate more stake or do any of these kind of more complicated Web3, complicated Web3 mechanisms, which are not really complicated per se, right? They're pretty simple. They're kind of like the fundamental building block of what the space is. But unfortunately, it's just these traditional institutions just do not have the capability of providing this at the speed that crypto moves. And additionally, they usually target ultra high net worth folks and other institutions. So it's never made for the average consumer, the person who is actually engaging with crypto on the daily, right? Like as said, it's not exactly a crypto native entity. So this leads us into introducing decentralized asset custodians, which is what Entropy is building on. So in contrast, a decentralized asset custodian is a trustless protocol for securely storing crypto assets. Trustless or trust minimized, pick your poison. I know we all hate this term being thrown around like that, but we'll get more into that, why it's actually that in a bit. It's a crypto native analog for cold storage mechanisms via threshold signatures. Or you could also use other advanced consensus-centric cryptography. I know, for example, you could say Gnosis multisig is a decentralized asset custodian. And it might be, especially when we start talking about Gnosis chain and things like this. But generally, we can also construct these things with threshold cryptography. In addition to this, a decentralized asset custodian is something that I would say is transparent, decentralized, and community-owned, maybe by a DAO, right? Radically inclusive of everyone, regardless of net worth. It could be a DAO, it could be a bank could use this, or it could be a trading desk, it could be your family. It's kind of generally it's a protocol that can be built on a lot of this. So something I like to say is let me move over here. What AMMs did to centralized exchanges, decentralized asset custodians, will do to centralized custodians. So Entropy, please clap. Oh, I love that joke. That's about the third time I've done it. It doesn't get old yet. I love that. So Entropy is the first ever entirely trustless decentralized custodian protocol. It's sort of like multi-factor authentication for your private keys, except decentralized. We would say this, I like to say this is a new paradigm for blockchain interaction, because once you really start understanding how you can use Entropy and this SDK to sort of interact and change the UX around how you actually work with other blockchains, you start seeing how different it is and how much better it is as well. So the reason why we call this trustless, or you could say trust minimized, is it's built on top of T of T threshold signature algorithms. So you're probably familiar with T of N. We'll get more into this in a bit, but T of T is what we use, and this requires everyone to be in consensus with everything to actually go ahead with the signature. So if there's any malicious parties, there's not going to be a signature on the output. So therefore, there is no risk to funds if the network is hacked. It also works on pretty much any blockchain. We're starting off with ECDSA first off. So it works on any blockchain that offers ECDSA signatures. And this is most, blockchains right now. This is, Ethereum, Bitcoin, pretty much all the major ones. And what we're trying to build is a simple signing API to integrate in your wallet or your dApp. And we also have a few more things coming up, which I'll talk about in a bit too. So what does it do? Entropy enables you to do really cool stuff like address whitelisting, spending limits, time lock transactions, multi-factor authentication, which is actually a really important tool in the blockchain space that we're not really kind of fully explored yet, right? I mean, we have hardware devices that people use, and they have like clunky UX and everything, but truly like decentralized multi-factor authentication for your private keys doesn't quite exist. And this is something that Entropy wants to actually really lean into and work on. On top of that, we also want to work on arbitrary programmable rules. So for example, like we put here, an Entropy node receives a signature request from Alice and retrieves the on-chain constraints for Alice's key share. So what happens here is if you were to set up some rules or some conditions on how your transaction can be signed, we check. The nodes will all check this, and they do this in consistency with each other. Does the transaction metadata satisfy the retrieved constraints? And so if you set up rules and we execute those rules and they say, no, that transaction does not satisfy these constraints, then the Entropy node terminates and the protocol doesn't go forward and your transaction doesn't get signed. Otherwise, if your rules do satisfy it, say, for example, you set up something on a whitelist and it is within that, that whitelist, that address, the recipient addresses, then the Entropy node randomly selects a group of nodes from our network and it will sign your transaction with you. Notice with you. So you retain that, you should retain a part of the share and you work with the network to sign it. So this is where that T of T threshold signing comes in. So you actually have to work in conjunction with the network to sign that transaction. So if at any point in time the network is trying to get you to sign something you don't agree with, or you're trying to fool the network into signing something that it's not supposed to sign, everyone has to be in consensus on the exact same data that we're signing. Otherwise, the protocol just will not proceed. So again, on top of this, like what we can build from this is pretty powerful, like DAO-controlled signing rules. Those are quite powerful, right? So now we can imagine DAOs being able to control rules and the ability and controlling the ability to interact on different blockchains based on decentralized private key. It works natively on any blockchain. Mostly, again, you have to with certain cryptography if it's not exotic or anything. And all of this is decentralized. And so basically, we have a decentralized network that we're going to be pushing out, hopefully in Q4 this year, that will allow us to achieve all of this. So let's take a little example. Let me have to move back and forth. So staking providers, really great example of like how you can leverage Entropy for this, right? So we have a staking provider, say someone like, somebody you delegate your tokens to stake for you, say on ETH or Cosmos or even Polkadot, right? So we say, Alice, what we could do very easily is say, hey, I want to separate my ability to sign a transaction from my ability to vote with that same key. Now, there are native solutions to this in Cosmos, for example, but not in a lot of other networks that do this. So instead, what we could do is just have a very basic Entropy rule that says Alice retains a voting share, and then we only have the staking share delegated to the staking provider. So now, with a single private key, we're able to delegate two different functionalities to two different people. We can say Alice retains voting rights, and the staking provider retains staking rights. So this means maybe the staking provider can redelegate or add more, or even like withdraw to a different address that you set up. But the only thing Alice can do is vote. So again, this lets you delegate to another person, say, I want them to run a node for me. I want them to worry about all the technical stuff that I don't care about, but I only want to engage in the political process of the community. That works for us. So basically, Alice can say, hey, I'm going to use the Entropy network to try and sign something. And the network asks, does the share have the appropriate permissions? If the share is yes, then we can sign the transaction. So if Alice tries to vote, she'll sign the transaction with the network. If Alice tries to do anything other than vote with that share, say send funds away from it, or maybe try to mess with something that the staking provider is doing, then it's going to say no signature is created. The shares do not have that rights to that. On contrast to that, maybe the staking provider says, hey, I want to try and vote something. I own all this tokens and I run all these nodes, but I don't have any of the political value. I don't have the political share. So they try to do the exact same thing. They try to maybe vote on some controversial proposal. No signature will be created because the staking provider doesn't have rights to vote. Again, they work with in all of this. Sorry. And also on this is, we can talk about a stolen share. Say maybe somebody steals Alice's share to vote, right? Yeah, technically, we will be able to say that Alice would be able to vote and Dante, with the stolen share, would be able to vote and maybe sign and participate in that political process. But again, it comes with no risk of loss to those funds or even the custodian. Say, if they steal, they have to work with the Entropy network to sign it, meaning they can only really do the functions that they get from that share. So again, if somebody were to steal Alice's share, say her laptop is hacked or she has some ransomware, or not ransomware, but malware that tries to steal her keys, they're only going to take the shares that she has. So it allows you to really trust minimize yourself to this and really delegate and add multiple layers of security here. So there is a really minimized attack surface for a lot of this stuff. And it really allows you to split up those roles and really enable just powerful security. So we'll get into the more technical stuff because I'm a cryptographer and I like to talk about cryptography. So we use, again, TFT threshold ECDSA. So getting more into what that means, if you're familiar with T of N threshold cryptography, essentially what that means is we take N shares, right? We could say that there's 1, 2, 3, 4, 5 shares. So you could say, with T of N security, you would say, oh, well, we can say 3 of 5 shares are needed to make a signature, right? So instead, with T of T security, we say all 5 of these shares are needed to make a signature, right? So if any of these shares goes missing, then there's not going to actually be able to sign something. All parties must agree on signing the same message. If any disagree, then it will not be signed. And because we use TFT, there is no quorum of signers on the Entropy network that have signing authority without the key owner's input and or their second factor. So this gets into that as well. So what Alice is able to do when she generates a key on Entropy, she's going to be able to say, hey, I'm going to hold a share, and additionally, possibly, my second factor authentication device is going to hold a share, and the network is going to hold a set of shares. Now, we will do a whole process to ensure that sharding occurs in this network and that there's no loss of the keys on the network as well. And so Alice only has to worry about her other keys. So again, functionally, this means that if the network is ever hacked, the worst case is denial of service, never fund loss. Now, you might say denial of service is fund loss, but this is only true if we were custodial. But Entropy is a non-custodial solution in the beginning. And what we're going to be doing, at least in the very beginning, is that users will retain their seed shares, so that way they can put them in a very hard-to-get location, or whatever they do to back up their keys, and they can still retain full signing functionality if they need be. This is what we would call self-sovereign recovery, right? So the issue with this is obviously you still have to retain your seed shares. Now, what we want to do at Entropy, and this is kind of leaking a little bit of the secret sauce, is we want to be able to work on doing social recovery. And so now when we start engaging with DAOs and we start engaging with a lot of decentralized parties and community organizations, well, there's no longer just an Alice. There's suddenly a bunch of people. So now instead of just being an Alice, well, what we need now is to do distributed key generation between a bunch of people and have social recovery with all of them. And now we have the Entropy network that holds some of these shares. And now you have to coordinate with your DAO to maybe sign a transaction again. And maybe you can delegate certain rights and certain privileges and weights to those DAO shares. So if, in that case, if the keys ever get lost or something, or the network goes down, you can still work with your DAO or your collective to recover those keys in a self-sovereign recovery. So yeah, and that's Entropy. It sets the bar as a standard way to interact with the multi-chain world. The ability to it offers a vision, the roadmap, the ability to work with all these different chains in a blockchain agnostic signing API. Again, interact with any quote unquote layer 1 blockchain as long as we implement their cryptography. And the cool thing about Entropy is that since we are in this we only need a signing API or a signing algorithm, essentially we're just a pull request away from supporting a particular network. So if we, for example, Polkadot or maybe Solana, I think is actually a better example because Solana uses, if I'm remember correctly, Schnorr or EDDSA signatures, so not ECDSA. But obviously, we plan to add more signing algorithms. So again, it's just a pull request away. If you want to support your network and we don't have the native cryptography or whatever, we just need to implement that specific algorithm that works for you. Our nodes will implement it and run, and that's that. We close the UX gap by enabling a comfortable, standard, and secure experience across any chain. Traditional custodians are also extremely slow and more or less entirely resistant to integrating basic functionalities such as staking and voting. Entropy supports this natively and trustlessly. So that is it. That's our team. We have a few more people than this now. We're still hiring. We're looking for another engineer right now. So if you know anyone who wants to work on Substrate with us, and particularly maybe some WASM stuff, let me know. I'd love to chat. And that's it for us. Thank you.